Okay. Um, what is vertex form, you guys, first of all? Do you remember that? A times x minus h squared plus k, right? That is vertex form. Well, I'm given a vertex. Can I just plug numbers in and get this? A is the number that makes, because this is a parabola, A is the number that determines how wide this parabola opens up or how narrow it opens up, okay? But usually what we use is 1 for that. So in this case right here, I'm going to use 1, which means I don't write a number there because we imply that it's 1. X minus what, you guys? 2 squared plus what? 3. There's one equation. All I did is plugged the vertex, which is 2, 3, in for h and k, and I made a 1. A is the thing that determines, let me show you. If you have just y equals x squared, that parabola looks like this, okay? If you times it by 2, it makes it more narrow, like that. If you times it by 1/2, it makes it fatter, like that. If you times it by a negative, it turns it upside down, like that. Okay? So if you make a negative, it turns it upside down. If you make it bigger than 1, it makes it skinnier. If you make it less, between 0 and 1, it makes it fatter. Okay? And that's all a does. So, but the vertex will stay the same. Okay, so you can change a to be anything you want, but I'm just using 1 for it right here. Does that answer your question? Okay, so here's one equation. What would be another equation? If I want to keep the same vertex, what do I have to change, everybody? I just explained it. What do I have to change? A. I have to change a. What could I change a to? I could change it to anything I wanted. So let's make it semi-easy, not make it too big. 3. 3 will work. 3 times x minus 2 squared plus 3. There is another equation that has the same vertex as this one. They both have 2, 3 as a vertex, right? They're both parabolas. Okay? But this one's going to be skinnier than that one. Anything you want in for a. And it's going to change it to be a different function. So it says represent 2 different functions that have a vertex at 2, 3. Here they are. Now it says write one as a table. Which one do you want to write as a table? This one would be the easiest one to write as a table because you don't have to times it by 3 when you're done, right? So let's do that. 2, 3 is my graph. 2 is my x number. I want to go maybe on either side of 2. What numbers do you want to put in? Let's go -1, 0, 1, 2, 3, 4, 5. Should we do that? Well, we want to see the parabola. We want to see the vertex of the parabola. Since the vertex x number is 2, I want to make 2 the middle number I'm going to find, but you can use any x numbers you want. Okay? So if I put -1 in here, -1 minus 2 is -3, squared is +9, 9 plus 3 is 12. If I put 0 in here, -2 squared is 4, 4 plus 3 is 7. If I put 1 in here, 1 minus 2 is -1, squared is a +1, plus 3 is 4. If I put 2 in there, 2 minus 2 is 0, squared is 0, plus 3 is 3. And keep in mind, is that my vertex, you guys? 2, 3? And guess what? The other numbers are just going to go in reverse order of that. That's 4, 7, and 12. You can check them if you want. So, have I represented this function in 2 different ways? Yes, I've represented it like this, and I've represented it like this. I've represented 2 different functions that have the same vertex, but one as an equation, one as a table. Well, this one is the same as that one, but it says represent one of them as a table. So we counted this one and this one as the same. Does that make sense? Okay, now could we graph all these, you guys? Yeah, let me show you what they would look like. Yes. That's what I've shown right here. If you have something like x squared, it's this one right here. If you put a number bigger than 1 in for a, like 2, it makes it skinnier. If you put in something between 0 and 1, like 1/2, it makes it fatter. And if you put it negative, it turns it upside down. And so this a right here, all it does is changes how fat or narrow it is, or whether it's upside down or opening up. Got it? If it's positive, it opens up. If it's negative, it opens down. Does that make sense? And you guys, right here, if I graphed these two, if I went to 2, 1, 2, 3, both of these graphs are going to be right here at 2, 3. There's its vertex, 2, 3. But one of them, the second one's going to be skinnier because it has a 3 in front of it. That's what those would look like. They still have the same vertex, right? Does everybody see that? But these are different. Cal, go put that on my desk. Okay, you've been playing with it the whole time. Go. All right. Okay, any questions there? Do we understand that? Now, I gave you a homework assignment last time. Did you guys get that one problem done I gave you? Okay. What was that one problem? What was that one problem? I gave you what? I gave you a table and you had to make the equation for it?
Yeah, number of cubes. It's like a James equation.
Well, we're going to start over. Is that what I gave you from homework? No, I think I gave you something else for homework. Oh, that was the day before. Okay. I'll tell you what. I'm going to add to this, you guys. Here we go. Okay, I had you came up with an equation. What did I have you build? I forgot.
They were like the cubes.
Uh-huh.
It was like it was like 1 and then 3. And then it was 6.
Oh, I gave you the toughest one first. We're going to do that one at the very end of class, okay? Okay, so everybody get out your notes. I want you to write down our objective right here. Our objective is to write a function that describes the relationship between two quantities. That's what we are doing today. Now, this is cool stuff. Guess what, you guys? See this right here? This says Secondary Math 2 Honors. Guess what their objective was today? Today we will learn how to write a function that describes the relationship between two quantities. That's what you guys are doing. You guys are doing the same thing the honors students are doing.
That's because we are just...
So you should feel honored to do this, okay? Did you know that all the other secondary math classes in the school are way behind us?
This class is for us. Like, we learn the same thing, it's just slower, we get more help. It's not like we're losers.
Yeah. This is the same exact stuff. This is the same exact stuff that the honors classes is learning, and it's just like Tris is saying, you guys get 2 days to do it rather than 1 day to do it because we have class every day. But you guys need to be able to get it in these 2 days. Okay? Today we're going to do a little activity doing this. And I showed you this yesterday, the Tower of Hanoi, right? Did we do that yesterday again? Oh, I just didn't finish the showing you how long it took me to do this, did I? Because I messed up. It took me about, how long was I going? About 2 or 3 minutes? Okay, 5 minutes. You sure? Thanks, Sarah. Okay. So, well, we're going to skip that one. You know how we made a table, then we graphed it, and then we wrote an equation? That's what we're going to do. I got to review this real fast. What are the 4 ways to represent a function? Verbally. Okay, visually, which is a graph, right? Then how else? Table, which is numerically, they call it, right? What's the other way? An equation. We call that algebraic function, which is just an equation. Hey, by the way, there's another word you need to know that goes along with this. It's the word explicit. What did it say? Okay, good. Hey, how many of you guys get the same language arts as her? You guys remember hearing that word today? Definite, clearly stated. Does everybody hear that?
Oh, you are so.
You guys, when we write so right here, this chair. Because you can't pay attention back there. Okay. Okay, sit right here anyway. Okay, when you guys write an explicit equation like y equals 2 to the x minus 1, that was the one that we did with the Tower of Hanoi, that little game right there. That's an explicit, that's clearly stated. There is no messing up what x and y are. In other words, you can put numbers in for x and you're always going to get the exact y number. You can make a perfect graph from that. You can get a table of values from that. That is clearly stated. Just like Stephanie just read to us. It means clearly stated. That's what explicit is. The reason I bring this up is because on the Common Core, it uses this word. It says, write an explicit function, I think is how it states it. It says, write an explicit function. It means to write an equation. It means something that will clearly state it. An equation is what clearly states it. So do you guys understand that word? Okay, so what we're going to do now, I'm going to give you guys the centimeter cubes. And you're going to work in groups. I know the temptation always is, every time I hand these out to you, you guys start building these elaborate things, okay? I need you to focus a little bit more on what we're doing. Make the pattern. Because if you don't make the pattern, then you're not going to be able to do the other things. What we're going to do is we're going to make a pattern. I'm going to tell you what the pattern is. Then you're going to make a table that describes that pattern numerically. Then you're going to graph the points on a graph. And you're going to look at that graph and decide whether this is a linear function, a quadratic, or an exponential. You're going to decide which of those things it is, okay? And then you're going to write an equation or an explicit function for it. The very first couple we'll do, you guys will get these, and then I'm going to work into harder ones and harder ones, but you got to do it on the other ones. You got to do it on the easy ones first. So remember, you guys, I know this is always tempting to start building these elaborate things, but try to focus on what we're doing when I start doing it. So you two are going to turn around and work with those two. So turn around. You two are going to work with those two. You two are going to work with those two. You two are going to work with those two. Hurry back. You two are going to work with those two. You two are going to work with those two behind you. Will you come, Aaron, will you come sit in this chair over here? And you two will work with those two. And black, brown, or red? You guys should have spoke up sooner. Or green? Okay. All right. Whoops, I forgot to turn this off during that time. Okay. The very first one. You guys ready? This is what you're going to do. You're going to take, and we're going to do a 1 by 1 square. Then you're going to do a 2 by 2. Then a 3 by 3. Then a 4 by 4. You are going to make your table right here, but you're going to go beyond 4 by 4 with your table because you're going to see a pattern. Start right now and do this. Okay, now I think most of you, there's one or two groups I didn't get a chance to look, but most of you guys got it. Good job, okay? And I just want to review it just to make sure we all understand, because some of you guys were still confused. Cal and Cody, I need you to turn around. Okay, you're going to be famous now. You're on my video. Okay? And it's going on YouTube. I've had some other people watch them already. Yeah, it goes on YouTube. You guys, I connect it to my website, so all you have to do is go on my website and I collect a link. It's a video. It's a video, and whoever's name I say, the camera points on that person, and they're on the video. All right. So right now it's on Cal and Cody, the video camera. There is. Yeah. Yeah. There's a camera on this thing, and it points down, and it looks at you guys, okay? And it switches back and forth from here to there when I sing. Huh? Okay. All right. Okay, listen. Okay, we ready? Okay, right here, you guys, I have a 1 by 1, a 2 by 2, and a 3 by 3. That's all I drew right here. But you guys, some of you guys were asking me, how do you know what X stands for and how do you know what Y stands for? Well, X stands for the length of the side. How long was the side of a 1 by 1, you guys? 1. Of a 2 by 2? 2. Of a 3 by 3? Of a 4 by 4? And so forth, right? We got the pattern down. Now, how many blocks were in a 2 by 2? I mean, a 1 by 1 is 1. A 2 by 2 is 4. A 3 by 3 is 9. A 4 by 4 is 16, 25, and so forth. Okay, so we filled out the table. Now we're going to graph it. When you graph it, you've got to use, you got to increment in your little slash marks right here have to be in increments that are comparable to whatever x and y are. Well, x goes up in ones, right? So I'm just going to go 1, 2, 3, 4, 5, 6, and so forth. Whereas y, though, goes up faster, doesn't it? And we have to go clear up to 6. We don't have to go up that high. We're going to probably just go to 49. I'm going to put these right here in tens. So that's 10, 20, 30, 40, 50. Okay? I am going to graph these now. I've got to graph 1, 1. Well, 1, 1 is way down here. 2, 4 is about right here. And I hope you guys are graphing these because it's going to give you a hint on what the graph is supposed to look like. 3, 9. 4, 16. 5, 25. 6, 36. And 7, 49. Starts going up fast. It looks exponential, doesn't it? But it's actually quadratic. It's half of a quadratic, right? It's actually half of a parabola. A quadratic can sometimes look like exponential if you're only looking at part of it. Okay, so I've made my table, I've made my graph, and then I got to write an equation. I saw several of you have it. What is it? Y equals x squared. This one wasn't too bad, was it? You notice that whatever x was, y was the square of it. You see that? Like, Chase, I heard you ask him, Jax, do you have it down now? You understand why? It's x squared? Because if you square 5, you get 25. You square 6, you get 36. You square 7, you get 49, and so forth, right? So this function is y equals x squared. Now, hopefully you guys still have your pattern, your blocks out there. You guys still have those out there like it was? 1 by 1, 2 by 2, 3 by 3, 4 by 4? Because this is what I want you to do next. That was good. You guys got this one. That was impressive. More of you got it than I thought would, actually. That was good. Okay. No, I just know how hard this has been in the past, and I know some of you guys don't listen, and that's why sometimes I do. But I think you guys can get this if you listen. Hey, this is what I want you guys to do now. I want you to show me with your blocks how you would write this. I mean, not write it, but how you would show me with your blocks, your cubes. How would you show me x squared plus 1? I'm going to give you a minute. Me and Mr. Cooper are going to walk around. We're going to see who's got it. Go. I'm going to give you a minute. X squared plus 1. Okay, hurry and do this, you guys. No, I'm not asking you guys. I'm asking you to show me with your pattern blocks. Now, that was good. Now do this one. That's it. Okay, now do this one. Show me what this one looks like. All right. Let me have your attention now. Stephanie. Okay. Now, all you had to do to this one is add 1 to each one. All you had to do on this one was subtract 1, right? Okay. Yeah. On this one, you guys, if you made a table of values, if you put in 1 squared is 1, 1 minus 1 is 0, your first one was 0. Did you guys notice that? You had to take the 1 off. And if I could do negatives with these, I would do negatives. I was going to do x squared minus 2, but then I realized you would have had to have a negative 1. We don't have a way to represent that. We could probably invent a way. Okay, if you had 2 in there, it was 3 instead of 4, like in 2 squared, right? So that was kind of cool. All right, we're going to do another one of these. This is how I want the pattern to go. Listen carefully. I want 1 column of 2. That's the first one. Then this next one is going to be 2 columns of 2. Then the next one's going to be 3 columns of 2. Then the fourth one's going to be 4 columns of 2. And then put them all together to make rectangles. Okay? 1 column of 2, 2 columns of 2, 3 columns of 2, and 4 columns of 2. See if he's doing it right. One column of 2, 2 columns of 2. I want you to make the table, the graph, and write an equation. Okay, everybody listen. I've drawn the picture up here what your block should have looked like. 1 column of 2, 2 columns of 2, 3 columns of 2, 4 columns of 2, etc. If x is 1, y is, there's 2 blocks there, right? There's 2 columns and total of 4 blocks. 3 columns, a total of 6 blocks. 4 columns, a total of 8 blocks. 5 columns, a total of 10 blocks. 6 columns, a total of 12, and 7, a total of 14. Now this one right here makes it kind of easy to graph. When I graph this one, I'm just going to go 1, 2, 3, 4, 5, 6, 7 on this one. On this one, I'm going to do the same thing. 1, 2, I'm going to just put them in 6, 8, 10. They're in ones, but I only wrote the even numbers down. And I'm going to graph these points. 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, 6, 12. What kind of, is this making quadratic, linear, or exponential? Linear, right? You guys see that? That is a linear equation. Cody, please turn around here. Sit down. Okay, make a table. Okay, we made a table. We graphed the points. Now we've got to write an equation. Some of you came up with it. What was it? Y equals 2x, right? Because all I was doing in each case right there is doubling the number, right? And it was linear, so 2 times x. If x was 3, y was 6, that's double. X was 4, y was 8, that's double, right? So we knew it was 2x. Some of you guys wrote it as y equals x plus x. Is that correct?
Yeah, it's not simplified.
X plus x is the same thing as 2x. It's just not simplified, right? So if we write it in simplest form, we write 2x. Okay? All right, now, I want you guys to write this same one, except for I want you to write y equals 2x minus 1. Not write it. I want you to show me with your blocks what y equals 2x minus 1 would look like. Show me with your blocks what y equals 2x minus 1 would look like. We're not multiplying, but to drop the parentheses, you can think of it as multiplying, because this right here, when you have a minus sign in front, see, this was like a positive 1, but that doesn't change the signs. 1 times 4x is 4x, 1 times 2 is 2. I can rewrite this one without the parentheses up here by writing 4x plus 2, right? But right here, I'm going to multiply that negative 1 through. It's going to change the signs, and I can drop the parentheses, and now I combine like terms. Okay, Chase?
On the top one, plus 1, that would make that correct, but then you still have to apply the 1 next to the left side.
You have 1 times 2 is 2, and you can drop the parentheses.
I got 3x plus 3, is that right?
Okay, so well, yeah, let's look at the answer. What's x minus 4x? It's negative 3x. And what's negative 5 minus 2? It's negative 7. Negative 5 subtract 2 is negative 7. I think those of you guys who were here at the first of the year when we did this are understanding. Those of you who just checked in probably aren't understanding it as well. So that's who I'm getting the questions from. Okay, how many of you think you understand how to do that? Chase, do you think you get it now? Okay. All right, Sariah, did you have a question? Okay. All right. And the last thing, what's the last thing we got to do? The last operation. F times G. This is where we're going to multiply, you guys. I have x minus 5 times 4x plus 2. I'm going to move this up. Okay, so this time now we're multiplying f times g. This is where we have to distribute, right? So I've got to times the x by both terms in the other binomial, and the negative 5 by both terms in the other binomial. Okay? And when I do this, so I'm going to distribute the x. X times 4x is 4x squared, because x times x makes x squared, you guys. That's a short way of writing it, right? X times 4x. I'm timesing 4 times x, right? Exponents are just a short way of writing multiplication. If I have two numbers that are the same, I'm multiplying together, instead of writing them twice like this, I can write it once with a little 2 up there, meaning I'm timesing it by itself twice. Do you understand that? It's x times 4x, the whole term. Terms are separated by plus and minus signs. So 4x is a term altogether. So I'm timesing x times 4x. X times 4x. That's 2 x's being times together and 1 4, which makes 4x squared. Nicole, if you were to add those, x plus 4x would be 5x. If we were adding, that would be a totally different answer, wouldn't it? But we're not adding, we're multiplying. So we have that, okay? Now I times the x by 4x, and now I got to times the x by 2. What's x times 2? 2x. Since I don't know what x is, I can't combine those. Okay, so I've distributed the x. Now I got to distribute the 5, the negative 5. Because do you know what x is? No, if I knew x was something like 5, then could I go 2 times 5 and get 10 right there? But since I don't know what x is, I just have to leave it as 2 times x, which is 2x, okay? Now I distribute the negative 5. Negative 5 times 4x is negative 20x. Why is it negative 20x? Negative 5 times 4 is 20, right? Times x is negative 20x. And negative 5 times 2 is negative 10. Do I have any terms there that need to be combined, Cal? Soraya. The 2 and the 20. Thanks for coming to Cal's rescue because he probably didn't hear what was going on. 4x squared minus 18x minus 10 is the answer. How many of you think you could do a problem like that if I gave you another one? Okay, I'm going to give you another problem here where you have to do all three of these things. But first, before I do that, I am going to, we already wrote down an objective, so I want you to write down this part right here. The operation, and you don't need to worry about that last one right there, because I actually took out the division one, because we don't have to do that one for what we're doing. Okay, I have the operation. There's sum, there's difference, and product. That means add, subtract, and multiply, right? I don't know if this would help you guys or not. Do you think that will help you? No. Then let's move on. All right, I want you guys to do this one right here. Here's my two functions. Here's function f. Here's function g. Here's function f, here's function g. I want you to add those two functions together, then minus them, and then times them. This one's a little bit different. F is your favorite letter? Least favorite number, and I always make you write it? How did it just... It looks like we have some real issues in here, Mr. Cooper. Soraya. Huh? I'll show you up. Did you guys get arrested?
No, I'm kidding. You would never do that. Ew, I would never do that. I don't do drugs. I would never. I don't. I know you don't.
3x squared plus 5 over x.
Yeah, you guys, this one right here would be 3x squared plus 5 over x. Guess what? Do we have any like terms there? No, we're done. That's all you have to do.
And then
Look at this one. 3x squared minus 5 over x. Guess what? No like terms. You're done.
yeah, but there's still an x.
Next one. 3x. No. This is an x squared, and this is an x in the denominator. Suffice it to be that right there. And we have 3x squared times 5 over x. This one does simplify. This one does simplify. Does anybody know what it simplifies to be? What? Well, actually, this x will cancel with one of those x's.
Wait, why are you canceling those?
Because one's in the denominator. An x in the bottom divides into one of the x's on the top. There's two of them. X squared means x times x, right? It'll cancel with one of them. And what are we left with? 3 times x times 5, which is 15x. In addition, you can't cancel because you're not dividing. You're not dividing this one by that one. You're dividing by 5 by that one. Whereas when you multiply, division and multiplication can be all done together. Huh? Your dad will hear this.
My dad knows I don't get high.
I believe you, Sarah. I know who your grandpa is, so.
Sarah.
Trista, I meant. I believe you, Trista. Yeah. Okay. Hey, you guys. See if you can do this one right here. Last example, then I'm going to give you your homework assignment.
Homework after all of this workout done?
Yeah.
So we have homework yesterday.
Elena and Shania, come on. You guys haven't been listening the whole class. Listen.
Wait, can you?
Yeah.
So it's x squared minus 1.
Okay, hey you guys, this one right here, x squared plus 4 minus x, right?
Plus, it's F minus.
Oh, that one's f minus, isn't it? First one's f minus, you guys. I was thinking we were going the same order. Well, when you minus, to drop these things, the parentheses, you got to subtract. You got to just change the signs of everything inside. Think of it multiplying a negative 1 through. That's going to be minus 4 plus x.
But
Yeah, you always just change both signs. Always just change both signs. When this is a minus sign out here, you guys just change both signs. By the way, we should write this as x squared plus x minus 4 in that order. So there's f minus g right there. X squared plus 4 plus x. This one's just going to be x squared plus x plus 4. The signs don't change, but to write it in descending order, that's how you do it. Who asked me that? Is that the addition? No, I just did it for you right here. F plus g, see? You can't add x squared to x. They're not like terms. Like term means they have the same variable to the same power. You learned this in whichever class you were in, or the first of the year. Remember? You remember? Okay, you guys, f times g. F times g would... On the last one, because it was plus. Only on minus signs. Okay? Last one, I got to times this. I got to distribute the x squared. I'm going to get 4x squared minus x cubed. How many of you guys had that? Good job. That says 4 minus x, yep. And so you get 4x squared minus x cubed. If you want to write that in descending order, you can. Now, you guys have an assignment.
Okay.